Already we have seen this one approximations of figure 8.98 using DCT and the normalization array of figure 8.30 B. Here A is sorry, this is 32. 32 Z is greater than 62 Z. 62 is sorry. Here 16 is greater than 32 Z. This 8 is greater than this 16 is Z. This is 18 8 Z is greater than better than 6 Z, and then from this 8 is greater than this 4 Z, and this 4 compared to this 4 is 2 Z is 4 Z, 2 Z is better than this 4 Z. This is only Z. This Z is better than 2 Z. Normalization. You see, DCT normalization. And DCT and normalization array. That's all. Jpeg versus Jpeg 2000. Pros of Jpeg: low complexity, memory efficient, reasonable coding efficiency. Cons of pros and cons. This is pros part. This is cons part. These cons of Jpeg: single resolution, single quality, no target bitrate, blocking artifacts at low bit rate, no lossless capability, poor error resilience, no region of interest. Jpeg versus Jpeg 2000. Jpeg 2000 improved coding efficiency, full quality scalability from lossless and lossy at different bit rates, spatial scalability, improved error resilience, regions of interest can be coded with better quality, more demanding in memory and computation resources, scalability. Some imagery may be accessed by users with different link speeds and display qualities. High resolutions display with high speed link or small display with mobile radio link. We can have different versions for each desirable bitrate and quality. This is not efficient. Scalability, a single bit stream that can be accessed and decoded partially. There are two kinds of scalabilities: quality scalability, spatial scalability. Images having different qualities, sizes may be same or different. Spatial scalability, images have different sizes. Wavelet coding, the block diagram is same as before. Instead of DCT, we now use wavelet transform. Spatial scalability is achieved by reconstructing only the approximate image. Quality scalability is achieved by decoding only partial bit planes. Image input image transformer, a transformer output given to quantizer output given to encoder output is the compressed image. Wavelet coding, commonly used wavelets are tau pitches 9/7 by orthogonal wavelet for lossy compression and Lee Gale 5/3 bit by orthogonal wavelet for lossless compression. Lee Gale 5 by 3 bit orthogonal wavelet can be implemented using integer operations only. Instead of square blocks, standard allows for rectangular blocks called tiles. Each tile is coded separately. Wavelet coding. In this wavelet coding, quantization, each each subband may use different step size. It can be skipped for lossless coding. Entropy coding, bit plane coding is used. Most significant bit plane is coded first. Uh, yeah, a context-based arithmetic coding is used. Quality scalability is achieved by decoding some bit planes starting from MSC. Region of interest ROI. ROI region of interest. Selected region is coded with high accuracy. Example phase. There are two kinds of scalability: quality scalability, spatial scalability. Quality scalability is the images having different qualities. Images having different qualities. Sizes may be same or different. Spatial quality images have different sizes. Here, figure A, B, C, D. Three-scale wavelet transform of three-scale wavelet transform of with respect to Hor wavelets, tau pitches wavelets, symbols and Cohen tau pitches few 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 cow bioorthogonal bi-orthogonal wavelets. This is D. Cohen tau pitches few view few few view bioorthogonal wavelets. C is the symbols. C is the symbols. B is the Dow pitches wavelets. Hor wavelets. This is A. Here, the reconstructed images SK after compression at 0.25 bits per P divided by P by means of a Jpeg and Jpeg 2000. This is Jpeg 2000. This is Jpeg 0.25 bits per pixel by means. Image segmentation. Goal Goal identify groups of pixels that go together. That is that one goes together. Types of segmentation. In this type of segmentation, semantic segmentation assign labels: tiger, water, grass, dirt. Tiger, grass, water, dirt. No water. This is no water. Here. This is water. This is dirt. Types of segmentation: figure ground segmentation, foreground, background. This is the background, this is the foreground. This type of segmentation done by Crafcut, the focus of project. Types of segmentation: co-segmentation, segment common object, co-segmentation, co-segmentation, segment common object. So segmentation is relatively recent line of work in segmentation. Historically, it started with the segmenting the same object instance in multiple images, but evenly grew to segmenting out the instance of same category. Application as a result, useful in graphics applications, image matching. Application as a result, image matching. Image matching. Okay, this image matching. Full, full. Okay. Application speed up recognition. Speed up recognition. Okay. Super pixels also see last slide. Make computation faster. Region proposal speed up detection. Speed up detection. Application better classification. By getting rid of the background, we can remove irrelevant information. Irrelevant is information removed. Okay. Then here also. Okay. By getting rid of the background, we can remove irrelevant information. History before computer vision. Gestalt theory. Whole or group. Whole is greater than sum of its parts. The relationship among parts can yield new properties features. Psychologists identified a series of factors that predispose set of elements to be grouped by human visual system. Gestalt factors. Here these all are Gestalt factors. Outline. Segmentation, clustering, graph-based segmentation. Segmentation as energy minimization. This one is the new stuff. Segment as clustering, K means GMS and the EM means it. Segmentation as clustering. Pixels are points in a high dimensional space. Pixels are points in a high dimensional space. Color 3D, color plus location 5D, cluster pixels into segments. Cluster pixels into segments. Color 3D, location 5D. Color. Clustering is not used as a segmentation approach too much anymore, but highlights many of the key ideas still used in modern algorithms in terms of modeling appearances. Clustering K means algorithm randomly initialize the clusters under C1 to Ck. Given cluster centers determine points in each cluster. For each point P, find the clusters. Put P into cluster I. Given points in each cluster. Solve for C1. Set C1 be the means of points cluster I. If C1 have changed, repeat step 2. Properties will always coverage to some solution can be a local minimum, does not always find the global minimum objective function. Summation of I equal to 1 to k x for all Ct.